All right. So we got a function here, right? Anyone remember what this shape is called? Parabola. All right. And we're going to describe this function. Okay? So the first thing we're going to do is ask ourselves, is it even a function? If I have a graph like this, how can I tell if it's a function or not? Anyone remember what it's called? Tyler? The vertical line test. Linear, we'll get to that in just a second. I'm glad you brought that up. So, function could be either linear or nonlinear, right? So let's figure out, is it a function first, and then we'll ask if it's linear or not. So, I'm going to put my straight line right here. I'm going to walk it all the way across my line. I'm looking for any point where there's 2 points on top of each other, and it looks like I never have it. The entire time it's always just 1 point along that along that function line. So we know that yes, this is a function. Now that we know it's a function, we're going to ask, is it linear? What does linear mean?
It's a straight line.
A straight line. Does that look like a straight line?
No.
No. So is it linear?
No.
No. This is non-linear, which is something that is not a straight line. Now we're going to ask, is it continuous? Or, what's the opposite of continuous?
Discrete.
Discrete.
Continuous or discrete?
How can we tell if something is continuous or discrete? Arish.
Something continuous, it will like go into one line.
Exactly. If it's continuous, we see one nice line. It could be curvy, straight, wavy, doesn't matter as long as it's all a line. Alex, what does a discrete graph look
A
like?
discrete graph is when there are multiple points on like the graph that are not connected.
Exactly. Just a bunch of dots, nothing connected. That would be discrete. So what do you see here in this graph? Continuous or discrete?
Continuous.
Continuous. Do I have a y-intercept for this function?
Yes.
What are the coordinates for my y-intercept? Approximately. 0, negative 6. Boom. Do we have any x-intercepts here?
Yes.
How many do we have?
2.
2 of them. Am I going too fast?
No.
Okay. What's one of my x-intercepts here?
-9. 0.
Negative 9, 0. Boom. What's my other one?
5.
5, 0. Boom. Right there. Okay, now that we know the x-intercepts, I can write my positive and negative intervals. Okay. Which part of this little U-shaped function, which part of it is above the x-axis? What part is above the x-axis? Look at it real quick. Is there any part of our function above the x-axis?
Yes.
Yeah. Do you guys see what those parts are?
Yeah.
What parts are they?
When x is
Just even before we get to the interval, just looking at this little function, what part of my function is above the x-axis?
the two arrows above.
The two endpoints, right?
Yes.
This little guy right here, and this little guy right here. Right?
Yeah.
So here's -9, right? My positive part of this function is anywhere less than what?
Oh. 9.
My x-intercept is right here, right? And this green section is to the left of -9. So I'm above the x-axis anywhere x is less than -9. And my other endpoint here is also above the x-axis. At what point does that function cross the x-axis? At what number? Right here.
5.
At 5?
So x has to be greater than 5. in order for
That's
it
right.
to be positive.
So if my function wants to be positive, I have to have an x value greater than 5. What part of my little U-shaped graph is below the x-axis?
That big bulge.
The big U-shaped part right here. All of that. I'm going to do it in red. Right? That's all below the x-axis. So this little dip here, where does it start?
-9.
It starts at -9. Give me a thumbs up if you see that it starts at -9. Where does it end?
5.
5. So my function is negative anywhere in between -9 and 5. Well, if my x is in between them, it's got to be greater than -9 or less than +5. Okay, when we're writing a combined interval here, my little alligator mouths are always going to be pointing to the left and eating to the right. Because that's just how a number line works. The bigger numbers are to the right. Any questions I could answer on the positive, negative aspects of it? Quick show thumbs. How we feeling about those intervals? We doing okay? Doing not okay? Doing bad? What's that? Okay. Okay. Let's move on. Relative maximum. Everybody see a relative maximum on this function?
No.
No. So there is none. Anybody see a relative minimum on this function?
No.
Is there any part where it dips down low, Tyler?
Yeah.
Approximately where is it at?
-2,
Perfect. Negative 2, negative 6.25. Right there. So now that I know I have a relative minimum, I can use that to determine when my function is increasing or decreasing. So let's start with increasing. You guys okay back there, Davis? Increasing. So I know my turning point is at negative 2, right? That's where everything changes. I'm going to make a little line here through negative 2. Just like that. Okay? If we imagine our roller coaster from left to right, I'm going down, down, down. I hit negative 2 and I start going up, up, up. So am I increasing to the left of this line or to the right?
To the right.
I'm increasing to the right. Right?
Yeah.
So that would be anything greater than negative 2. Do you need to step outside real quick? Davis, you okay? Okay. You're being kind of distracting right now, to be honest. Right? Anything greater than negative 2 is increasing. And anything less than negative 2 is when I'm decreasing. I'm dipping down, 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 boom, until I hit negative 2. So my function is decreasing when x is less than negative 2. So it's very important we understand that if I'm trying to find my positive and negative, I'm using the x-intercepts. But if I'm trying to find my increasing, decreasing, I'm using my max and my min. Okay? Different points helping us understand different things. So we've identified 11 things, but we have more to identify. Does this function have a line of symmetry? Give me a thumbs up if you think, yes, this does look symmetrical. Thumbs down, no, it does not look symmetrical. I see Ava's got a thumb up. Adriana T has got the thumbs up. Yep, Chloe's got her thumbs up. And we've actually already identified the line of symmetry, right? Where is my line of symmetry?
Negative 2.
At the relative minimum. Exactly, which is at negative 2. So the equation of that line would be x equals negative 2. With a parabola, something that you'll notice is that my relative min or my relative max is always also going to be the line of symmetry. Right? Because if I were to draw a parabola like this, right, this little dip here creates an identical mirror image on both sides, right? Same thing if it was upside down. My relative max is also my line of symmetry, okay? This is only for parabolas. If we got some weird thing, then it won't be. But for parabolas, that's what we get. What else? Oh yeah, end behavior too. Let's do that. Number 13. End behavior. As x increases, f of x does something. And as x decreases, f of x does something there too. What do I notice about both my arrows on this function?
They're both pointing up.
They're both pointing up. So as x increases to the right or decreases to the left, either way my function is increasing in terms of end behavior. Now again, don't get this confused with our increasing, decreasing intervals, right? End behavior is just looking at the arrows. The increasing, decreasing interval is looking at the full function. Okay? That's a lot of stuff, isn't it?
Yeah.
We didn't even do domain and range. But we will. Not right now. On the test we will. No, we're not going to worry about that. We'll talk about domain and range on Wednesday. All those very nice descriptors giving us a great idea of what's going on with this function. Quickly glue in the second graph once you get it. I worked really hard on these graphs, and you're just like, oh my god.
Yeah, I'm kind of tired of it. Oh, that's
What? Are you questioning? I did.
I decided.
Most teachers just press the this way. Look,
Which way are we going to put it?
Yeah, I think it's not. Magical blue stick.
Oh my gosh, I missed it.
Ah, great question. The axis is a little bit hard to see yet.
Which way are we supposed to do it in?
It should be going in like this. Just look at the axis. Should help. That's what our graph should look like. So real quick, we're going to find the exact same 13 things. Is it a function? Is it linear? Continuous? Blah, blah, blah. So see if you can get started figuring out at least the easy ones. Like, is it a function? Is it linear? What are the x-intercepts? What are the y-intercepts? Relative min, relative max. If you're stuck on the intervals, just hang tight. Let's see if you can fill out as much as possible, because that's what our worksheet's going to look like.
What is that? What is that?
After all this time, this guy doesn't even know the function.
What is a function? It's okay.
Wait, we're getting this one too. Wait, actually?
I mean, is it a function?
Okay, this is a lot of
Oh,
steps.
there's three. There's three x intercepts.
I'm gonna cry.
Don't cry.
3.5.
Is it a function?
All right, let's come together real quick so we can get started. Is this a function? Thumbs up for yes, thumbs down for no. What do you think? Ooh, ooh.
Yeah, what's the function? Oh.
Well, let's try the vertical line test. So far, so good. So far, so good. All the way across. Yeah, there's nowhere where there's 2 points on top of each other. This is a function. Is it a linear function? No. Is it continuous or discrete? Continuous. All my points are connected with one nice line. It's a crazy looking line, but it is a continuous line.
Yay!
All right.
Wait. Supposed to change.
That's okay. Y-intercept. Where do I cross the y-axis here?
0, -9.
0, -9 looks about right. Now the y-intercept doesn't really do anything for me. It's not going to help me write the intervals for increasing, decreasing. It's not going to help me write the intervals for positive and negative, but we are going to identify it. Okay, so there's my y-intercept. How many x-intercepts do I have? Ooh, I got 3 of them. Where's my first one at?
Negative 8, 0.
Yep, we got 3, 0, -8, 0. I'm going to start left to right. -8, 0.
Negative 3.5, 0.
Yeah, I mean,
I think it's negative 3.5.
we'll call it -3.5. It's not super precise, but it will be on the test. Don't worry.
Kind of looks like negative 3.6 or negative 3.4.
We'll round it to 3.5. Yeah, good eye. Let's just call it 3.5 so we're all on the same page. All right. Now that we know the x-intercepts, we can figure out when my function is positive. My function is positive. If you remember, this is where we highlight it. So at my x-intercepts, I'm going to do a line. Boom, boom. What's that, Aaron? What's up? You say you're listening to the notes? Good. So I got my positive section up here, another positive section all the way forever to the right. I've got my negative section down here, and another negative section all the way forever to the left. So I have 2 intervals for each. My positive interval is from -9 to -3.5. -9 to -3.5. Is it -8? Oh, you're right. Good catch. Yeah. So from here, -8 to -3.5. And anywhere greater than 3. What's one of my negative intervals here? Yeah, Tia. Sure. my negative intervals, we're looking at anything less than -8. And this blocked in section in between -3.5 and 3. I'll give you guys a moment to catch up.
I kept my clicker in upside down. I was so confused why you had negative 2 on it.
Oh, you glued it upside down? It's okay. Just flip it around.
I already wrote everything.
Did you want a new little square now? Do you want a new square?
Does it look like it has a line of symmetry?
You give me the list.
Yeah, I don't.
I already did all of it.
Honestly,
That's okay.
it does not. Is this the line of symmetry?
You finished?
It kind of looks like it does have symmetry, but it doesn't.
It is funny.
Does it have it? I'm actually confused.
All right. Got our positive, negative. Let's take a look at our mins and our maxes. We got a couple. Okay, number 8. Do I have any maximums here? Do I have any little hills?
Yes.
Yeah? I've got it right here. Looks like it's at,
-6.5, comma 6.
this one we'll call 6.25, comma 6.
Okay.
All right, so I'm going to do a line through my max. Do we have a relative min?
Yes.
Yes.
0.75, comma 9, negative 9.5.
Okay. Let's take it slow. So my relative minimum's down here. We'll call it 0.75, negative 9.25. Good enough. I'm not going to be picky about something like that on the test. I don't even think the test will have decimals like that, but it's fine.
Oh. Oh, I didn't need Stuck on number. I'm stuck on number 12. I'm just gonna wait until.
Yeah. Okay. Increasing. Well, we're increasing on this first interval here, which would be anything less than negative 6.25.
Yeah. And
Hold on. We hit this. Oh, you can't even see what I'm doing. So we're increasing. We hit this max. We start decreasing. In between negative 6.25 and 0.75. God, this one is annoying. So we increase, we hit the max. We decrease, we hit the min. We jump back up to increase. Anything greater than 0.75. So again, hopefully we're noticing that the x-coordinate of my max and my min are the only numbers I'm using in my intervals. Okay, you shouldn't be using any other numbers but your x coordinates from your max and your min. The same thing with 5, 6, and 7. My x coordinates -8, -3.5, and 3 were the only numbers that I used when I was writing my intervals for the positive and the negative.
Oops.
Everybody with me still? Okay, I'll give you a second.
Line of symmetry.
Actually, real quick, does this have a line of symmetry?
Kind
No.
Of, I don't know.
Nope. It does not.
It kind of looks like it does, but you have to draw an imaginary line. It's like in different
So if we drew a line through like the middle of the function, it
Yeah.
would be flipped and flipped, as opposed to just mirrored.
So when you turn it
Oh,
like
okay.
this.
No, I get it now.
Never mind.
Yeah. Think about it like this. Like if you had this shape on a piece of paper and you folded it along that line, you would see the same thing, right?
Yeah.
But if I had a shape like this and I folded it, it wouldn't be the same thing. It would be
Yeah.
opposite. You know what I mean?
Because if we
Yeah. So there's no line of symmetry. What happened? Did I crack my nose? I didn't even realize.
Yeah.
Last but not least, end behavior.
Oh, NBA. 13.
So as x increases to the right, what is my right arrow pointing? What direction? My right arrow is pointing up.
So x increases.
So as x increases, f of x increases. But to the left, what direction is my left arrow pointing? It's pointing down.
Down.
So as my x is decreasing, my function is also decreasing.